Welcome to our brief presentation.
This is Geaur.
And this is Zahid from Charles Sturt University, Australia.
The objective of this paper is the imputation of missing values. Figure 1a is an example of an original dataset that contains 15 records and 4 attributes, namely age, education, salary, and position. Often some attribute values can be missing in the collected dataset as shown in figure 1b. In this paper, we present a technique that can automatically impute the missing values. Figure 1c shows the imputed dataset. Imputation of missing values typically increases the data quality. For example, figure 2 shows that after imputation, the accuracy of the C4.5 classifier has increased significantly.
In this slide, we introduce the basic concepts of our proposed technique. Let us assume that Rij and Rip are the jth and the pth attribute value of the ith record. Let us assume that Rij is missing. The value appearing in the pth attribute is Rip, that is equal to L in this figure. The possible values of the jth attribute are x, y, and z, and the possible values for the pth attribute are L, M, and N. We impute Rij by using all other attributes, not just the pth attribute. The influence of an attribute in imputing Rij depends on the correlation of the attribute with the jth attribute. In the figure, Rjp is the correlation between the jth and the pth attribute. We compute a vote for each of the 3 possible values x, y, and z. The vote for x based on the pth attribute is first computed using only the value that appears in the pth attribute. Let us term this vote as Vxn. In computing Vxn, we consider Cxl, which is the coappearance value of x and L in the whole dataset. Details of this calculation can be found in our paper. We also compute another vote for x based on the pth attribute, considering all possible values of the pth attribute, not just the value that appears in the pth attribute. We term this vote as Vxs. Using Vxn, Vxs, and Rjp, we compute a final vote for x based on the pth attribute. We term this final vote as Vxp. Similarly, we compute the final votes for x based on all other attributes. All these votes for x are then summed up. This is the grand final vote for x as the imputed value of Rij. Similarly, the grand final vote for y and z are also computed. Finally, the value having the maximum vote is considered to be the imputed value of Rij.
We evaluate our technique on 9 datasets based on 2 evaluation criteria and compare the performance of our technique with 4 high-quality existing techniques, namely DMI, EMI, SVR, and IVLLS. In the datasets, we artificially create missing values by using 4 missing ratios, 4 missing patterns, and 2 missing models. So we have altogether 32 missing combinations, and for each combination we create 10 datasets. Therefore, we create altogether 320 datasets with missing values for each natural dataset. Figure 4 presents the average performance based on RMSE for 320 datasets for all techniques on 9 datasets. FIMUS clearly performs better than the existing techniques. We also present the number of times a technique performs the best as shown in figure 5. For 9 datasets, we have 288 combinations. Based on RMSE, FIMUS performs the best in 95% combination, and based on D2, FIMUS performs the best in 93% combinations. Thank you for your kind attention.